Hey, what's going on, everyone? Welcome to a new episode of Intellectual Horsepower. I'm Greg Jones with Engine Builder, and joining me as always is our co-host Dan Schechner. Today, our guest is Dave Visner of Visner Engine Development. Dave has been in this industry for a long time, doing some really cool high-performance engine work, as well as manufacturing high-performance engine components like blocks, heads, intakes, and even more. Dave, welcome to the show. Thanks for being here today.
Thanks for having me.
Absolutely. So, Dave, as I just mentioned in the intro, you've had your hands on a whole bunch of different things over the years, and Visner Engine Development does a lot in terms of engine builds and component manufacturing. Um, so we want to get into some of that with you today. But to start, it's been a little while since Dan or I have caught up with you. So give us a little update on what's been going on at Visner and what you've kind of been focusing on lately.
We got a lot of cool projects going on. We still doing all the billet products that we've always made, but we're also doing some 5.3 bore space stuff. We got a super stock Hemi project going on. Um, we our 5-inch water jacketed deal is coming along real well. We're really excited about that. Um, and just continue developing on all the different packages we have. Our 4.6 is still working well, and we're selling a lot of those, and always trying to make these things better.
Yeah, that's awesome. Very cool. So, Dave, something we've been asking people who, in your position where you've been in this industry a long time, is just kind of what keeps you motivated, what keeps you coming to the shop day in and day out, and does that kind of change over the years, or has it always been kind of one thing that motivates you?
I think it's the technology. As with racing, it kind of reminds me a lot of the medical industry and during wartime. We don't have a lot of rules, so we can just kind of go for it, if you will. And the more you learn, the less you realize you know. So we're always
Yeah.
testing and learning more stuff, and I'd say that's probably the best part about it. It's we're better this today than we were 5 years ago, and we'll be better 5 years from now than we are today. And it's a never moving, it's always moving target.
Hey, Dave, you mentioned the medical industry, and I know that wasn't just a random reference. Can you tell everybody if they're not aware, is that isn't that where you got started, or didn't you have some background there?
I went to pre-med. I mean, I was in college to go, and that was the direction I was headed until I decided to go down this road. I got family members that are doctors, and during high school and college, I thought that's where I wanted to go. But I ended up going this way and never looked back.
Was their reaction positive, or did they have some questions for you?
No, I mean, just can do what you want to do and do it the best of your ability, right?
Yeah. Where is that? Where does that sort of analytical, I think, approach that you take? Where does that come from? I mean, is that something that you've always had, or is that something that was developed along the way? How do you sort of frame up your philosophy and your approach to what you do?
Well, I think anybody who does this kind of work needs to take a very analytical approach to it. It's not just about testing, part A against part B. You got to take the time to understand, what those valve events or what that different port volume or cross sections, what those behaviors or how that's going to affect the behavior of the engine. So that's what we're talking about with always learning more. We um, we very rarely do we theorize things that work. I guess is the easiest way to describe it. Normally as we're testing, we see behaviors and trends, and then we go back and we start looking at it, and it's like, oh yeah, that's probably why this occurred, and we kind of figure out what's happening based on what we're seeing. Um, So the analytical approach, I think, is just a kind of that scientific methodology, if you will. Does that make sense?
It does. Yep.
Okay.
Yeah, absolutely. And so, Dave, we want to dive deeper into, that mentality and that thought process and kind of the analytics of it all as we talk about product development with you. But before we get there, you'd mentioned a couple of different engine combinations that you have your hands in. And specifically, I wanted to touch on the 4.6 small block platform because that's something that you and I talked about a couple of years back. And in doing so, it really intrigued a lot of our audience that you could have a 500 plus cubic inch small block.
Sure.
And, they just didn't really believe that it fit that qualification. So, along those lines, can you talk to that in terms of what still qualifies the 4.6 bore space platform as a small block?
At the time, that was the rules. Most racing organizations that we dealt with considered a small block up to 4.6 bore space, and then Pontiacs and Buicks, the FE Ford, those are all 4.620 or wider. So the rules were anything less than a 4.600 was considered a small block. So we kept it with a 400 main, and we kept it with a small block Chevy type head bolt pattern. And at the beginning, when the rules came out, and we were at small block weight, it was great because cars really fast, and obviously the engine is a big small block, and it made a lot of power and ran really well. Since then, most of the racing organizations have hung weight on the 4.6 combination, and yeah, made it in between, which is really the right place for it to fit.
Yeah, kind of even the playing field a little on the weight side of things.
That's right. So it's real popular with road racers. It's real popular with the small tire classes, things that small blocks run really well in, but having that extra power is an advantage.
Yeah, and again, referencing that article that we did a few years back, you were building those anywhere between 460 cubes to 560 cubes, correct? Is that still kind of where you guys are at with how?
It is.
Okay.
The most popular combination is our boosted combination, which is a 4,300 bore space, 4,250 stroke, and it works out to like 594 cubic inches. There again, most of the rules kind of lay out a small block is less than 500 inches, a 500 cubic inch maximum. So it falls in real nicely just under that. Then we do a 10.6 bore space deck height block that is more for naturally aspirated or nitrous applications. And most of those have a 4,750 stroke in them. And that's been a pretty good seller too with, that 540 to 565 cubic inch nitrous combination or naturally aspirated combination.
Yeah, yeah, very good. So, again, that small block article we did was a few years back, and it sounds like you've been doing even more in the with the 5.3, and then you mentioned the 5-inch water jacketed stuff. Do you want to just elaborate on some of that?
Yeah. So we've been fortunate to be in some proprietary um, racing that we got hired to do a water jacketed Audi engine,
Okay.
and it cooled really well and worked really good, held a lot of power. So that same basic design that we did on that engine, we have in a 5-inch bore space engine now. And we think it's going to be really great for drag and drive applications. Larry Larson has one that hopefully will be ready to go pretty soon. And he's a busy guy with a lot going on, but trying to get that S10 back out again, and hopefully we can run that a little bit this year. But also it's going to be great for the marine market. Big cubic inch boat motors that cool well. for the poker runs and the fast um, offshore style boats, would be
Yeah.
great.
Yeah. Very cool.
Sorry, can you elaborate a little bit, Dave, on your involvement with the drag and drive stuff? I know that obviously that's been a thing for quite a long time. I'm just curious how that works in with what what you typically like to produce over there.
Yeah, I've done components for a lot of those guys, and we did some big block Chevy heads for Andy Frost years ago when he did that deal over there in Dubai, and I forget what he even set the record at, but he set the streetcar record or whatever. Um, and we build a lot of manifolds, and we've done a lot of components for those guys, but we really haven't been what I would consider heavily involved in it. Um, but we have some friends that have fast boats, and we started talking about doing some marine engines, and so we built three of these 5-inch water jacketed billets, and Tony Bischoff over there built one of them, and it's been running and doing very well. And then Larry's got the other one, and the third one, we haven't done anything with yet. It's still sitting here. So, but we're going to get some testing done on it and try to prove the concept. Traditionally billet stuff doesn't cool really well. And some other people have recently done last few years have done a really good job with it, and they're doing drag and drive with full billet combinations. But we think the way we did it is going to work really well too.
Yeah, so Dave, without going into trade secrets of how you developed maybe the water passages or things like that make it work, what are some of the little tricks that you might have done different?
We come in with the water mid-engine, push it up alongside the exhaust side of the block, up and over the exhaust port area. So we cool the spark plug and exhaust side of the engine first. We go up and over the cylinder, the center of the cylinder head, come back down across on the intake side, and then out the center of the block. It's a deck plate design, so it's fully water jacketed underneath the deck plate all the way around, and the top of the cylinder is got full water. And then of course there's a lot of gun drilling in the block and on the cylinder heads to target critical areas. So it's probably not a whole lot different than what other people are doing. A lot of people like to do large pocketed areas, but a lot of thought has to go into that with not having stagnant water. Just doing a large pocket where the water doesn't have flow is actually worse, because then you got that shielding effect, and that water starts boiling that area, and then you create air pockets and that sort of thing. So a lot of thought goes into how the block gets cooled, and targeting the critical areas and making sure there's a flow path, not necessarily just a lot of water in it.
Yeah, absolutely. Very cool. Well, Dave, that kind of leads us into that product development discussion that we do want to have with you. Obviously you do a lot of that between all the components that you have your hands in. So how does that process kind of start? How much of it is stuff that you're coming up with, you're thinking of that the market should want versus the customer coming to you saying, "Hey, I need my engine to do X. Are you able to figure something out?"
Well, and when you're doing it for a living, you got to have paying customers. So the customer probably drives it the most. Having customers that have a goal in mind, and coming up with a way to help them achieve that goal. We deal with racing engines, so there's a lot of similarities between of components we make. Intake manifolds, they all have a plenum, and V8, eight runners, and so forth. But mostly it's tuning it and designing it around their needs and the class and the way they're racing it. So that's really the key to it, I think, is the rules and the end purpose of the engine.
Hey Dave, when you say customers have a goal in mind, how fully formed are those goals? I mean, is that something that you find you have to really walk them through? I mean, it's obviously going to differ, by customer, but for the most part, how involved are you in sort of fleshing out those objectives or what they want to accomplish?
These engines are very expensive, and people are very serious when they do them. So generally, they put a lot of thought into what they're trying to accomplish. When you start talking these billet engines, it's pretty easy to spend over $100,000 on one. So they're very intelligent. Most of our customers are really intelligent. They know their racing organizations and what they're trying to accomplish really well. And they come to us for our expertise, of course, but they generally have a pretty good knowledge of what they want and where the power needs to be and how to get there. Maybe not necessarily how to get there, but certainly what they would like to, where they would like to get to.
Yeah. So they're pretty realistic with their expectations. You don't have to talk them off the ledge too much.
Yeah, I think so. I mean, everybody wants to talk about huge dyno numbers and kind of the way it runs on the racetrack at the end of the day is all that matters.
Absolutely.
Yeah.
So Dave, you just mentioned, customers have a goal in mind. They generally, at that level that you're dealing with, have a pretty good understanding of what needs to be done. But, once you're actually in a development project for a component, how do you go about figuring out, what needs to change to accomplish that stuff? What does that process look like in terms of making those little tweaks, especially when you're working with billet and you can kind of start with a blank slate in a lot of cases.
Yeah,
How does that go?
that's really the beauty of the billet is we have a clean sheet of paper on all these components. Taking an intake manifold as an example, we would love to build the perfect intake manifold where it has the perfect plenum volume, the perfect runner length, perfect amount of taper, and so forth. But the reality is, it's still got to fit underneath the hood. It's got to fit on the block. It's got to have good entry angles coming into the cylinder head and so forth. So you really got to compromise a lot, when you do that. So, if you're building a boosted application, you might be looking and putting a little more emphasis on increase in the plenum volume. So, it decreases the turbulence and has a little bit better hole-to-hole distribution. And the runners might end up a little bit shorter from a pulse tuned length standpoint. So, if you're doing a naturally aspirated deal where you're trying to get every little bit of power, now you got to make sure that it has that right tuned length. So, you got to compromise a lot with making those kind of decisions about, what things are going to be important for their application, because very rarely can you make everything perfect.
Yeah, absolutely. Yeah, you mentioned you're limited by the platform and the block and what else you're using in conjunction with that. So you gave the example of an intake and some of those things that you might be looking for. How often are you guys, is it strictly a custom designed piece for one customer versus maybe a line of intakes that could apply to a combination?
Yeah. So, trying to build one manifold to fit a lot of different applications is really difficult. We've actually tried to do it. We've tried to do some heads and manifolds and put them on the shelf and have them kind of in stock, and it really hadn't worked out really well for us because our customers, we do customize things so much for the end user. Mm-hmm. I give credit to all the different companies out there that the Brodix and Darts and all the different people out there who do a large volume of stuff, because it's very difficult to make a one big block Chevy package that works in a lot of applications. And that's why, it's always been the engine builder's job to get that cylinder head, and you tweak it and you modify it. Most of our customers kind of expect a little more than that when they receive it. They're coming to us because they don't want to have to tweak it and modify it. They want to have it more of a finished product for their specific application. So I guess that's just the business where we happen to be in.
Yeah, no, that makes a lot of sense. So again, Dave, you mentioned some of those things that you'll tweak with an intake. How does that differ when you're looking at a component such as a block or cylinder, pair of cylinder heads? Obviously, there's a little bit more going on with each of those components.
I mean, we've always done cylinder heads and intake manifolds because those are what makes power. It's the volumetric efficiency side of an engine is usually where the power levels come from. Blocks and cranks and rods and all that stuff is important, but those are more reliability, durability and reliability components. So when it comes to like a block, obviously ring seal and the way you press, fit the sleeve and keeping that cylinder bore round, keeping it tied in there where it doesn't loosen up in the aluminum block, with the way the hat is designed and the way it's all held together. But keeping the blow eye down, the ring seal good, and I'd say the biggest thing on the blocks are ring seal and Capwalk. Tying the caps in a way where they don't move around much and stay nice and round for the
Yeah.
main bores.
Dan, you recently did a piece on Capwalk for us, so you can relate to some of that information, right?
Yeah, we sure did. I wanted to hear more. I wanted to hear what Dave's strategy was for preventing that. If he wants to go into detail on it, I'm certainly interested.
Yeah, so Hemi and Top Fuel blocks, they use a dowel stud. So we incorporate that same dowel stud. So the center stud is doweled, and that certainly helps. And we always widen the registers. So even like our small block Chevy or a small block Ford, the oil pan rail, most people when they make a block there, they keep that oil pan rail height, so all the stock oil pans and everything like that fit, and that's great, but having more material at the end of that main cap, giving it support and keeping that cap from walking is how we do it. You have to deal with the end seals around the main cap and up and around the timing cover with either modifying the oil pan or building a custom oil pan, but it really helps with keeping that cap where it belongs.
Got it. Yeah. No, I figured you had a good strategy for that one. So
Yeah, and then of course cross bullet mains work fantastic, right?
Yep.
Triangulating and tying it in from the side.
Mhm.
That's a good thing. Most of our blocks, if we don't offer it in a deep skirted way, then we offer it with a billet girdle that can tie it in from the sides.
I was going to ask just now what your take on girdles was, and if that's something that you use extensively. It sounds like that's something. Sounds like it might be
We do
an
almost
option.
all our
Yeah.
blocks we do with a girdle, and
Yeah.
then it just uses a flat bottom pan that can be O-ring, so you can drop down and access the mains. Um, you know, Doing a girdle where all the mains are tied into it is great, but you can't service the mains. And almost everybody who runs a power adder deal and in our drag racing world, they like to be able to check their main bearings and stuff. So we can't do that normally, but we do the individual main cap and then with a girdle, and then we tie it in from the side. So it would have a main dowel stud in the center,
Mm.
a splayed bolt that gives it a good clamp load to the block surface, and then also it would be tied in from the side into the girdle like a cross bullet main.
Got it. Yeah.
Nice. So Dave, like I said, with something like a block and certainly with cylinder heads, you got a lot more going on and a lot more to consider because you got so many other components that have to work in concert with it. So if you could, talk to us a little bit about the cylinder head development side of things. What are some of your theories and strategies in terms of you know, getting a best performing cylinder head?
So I've been very fortunate because I've worked with a lot of really great engine programs. I've worked in the NASCAR world, I've worked in the pro stock world. We've done pro stock engines, worked with pro stock engines, and obviously 500 mountain motor and small block stuff like the Australian stuff, comp eliminator and things like that. So the best way we found is have an engine program where they can afford to test and we can do a lot of different things.
Well, I guess Dave, to give you a little bit more in terms of like what I'm going through in my head is like you've got to have a cylinder head that makes the valve train live, right? Um, to some degree, but then you also have to have it, flow air well and all that. So what are some of those if you had to choose between a trade-off, what are you kind of starting with?
We definitely need to have the a window between the push rods. So relocating the lifter bores where you have a good trajectory path to the cylinder bores is key. So like on DRC3 as an example, um, big block DRC2s, a lot of most of your spread, I'm sorry, not spread port, symmetrical port stuff.
Mhm.
Most of those engines have a lot of bank to bank offset in the manifold, and you'll see a step in the step from side to side in the manifold where they're staggered. DRC3, what they did was they, rather than making number the first lobe on the camshaft number one exhaust, they made it number two intake. So then the second lobe on the camshaft was number one exhaust, and that staggered the lifter pattern, and that squared up the plenum and squared up squared up the plenum and the entries of the runners.
Right.
So we do a lot of things like that with custom lifter locations to allow us to kind of clean up that trajectory path, if you will. And then on the cylinder head side of it, the port development side of it, it's all about cross sectional areas nowadays. We obviously have the valve choke area right underneath the valve seat, and then normally there, because the air has to change direction, you get quite a bit of volume through the bowl, right? It needs to have a fair amount of volume through the bowl. Um, the amount of that you pull back the short turn in that line of sight and how much of the valve it actually sees really helps to determine the RPM range the engine operates on.
Mhm.
But then also we've spent a lot of time with the port choke, and the port choke is kind of up, you know, more like where you'd find the push rod choke area. And we play around a lot with, how we size the port choke. And that's really where the intake manifold starts, because that's where the taper starts from the port choke up to the entry of the intake runner. So how we size the port and lay that all in there is really the key to how good these engines run nowadays.
Right.
Um, um, I'm sorry,
And,
go ahead.
and Dave, are you using a specific port shape? Is there one that you found that works best in most of the applications you're dealing with, or does that differ still?
You know, because we've worked on some really good engine programs with within the limitations of the NASCAR rules, of course. NASCAR had a lot of rules with um, port heights and just they had a lot of rules with everything actually. But
Sure.
um, but you know that what we tested on that and what we tested with pro stock stuff, we definitely developed a port style that we like, and when we do other engine combinations, we adapt as much of that into it as we can, based on the other limitations of that engine package.
Mm.
So yes, I guess if you look at all our ports, they probably do have a lot of similarities, because a lot of them are based off of testing we've done with DRC twos, threes, and the different NASCAR combinations.
Yeah.
David, can I ask, what's your favorite type of engine to work on? I mean, you mentioned obviously having to, deal with restrictions from NASCAR, and Pro Stock obviously has its parameters that you need to work within. But is there like a particular type of competition engine that you find compelling, or that gives you some freedom?
I mean, the drag racing's probably been what's been best for us. But I'm not really tied into any one kind of racing. I kind of like engines from a technology standpoint, and I like working on them. And as long as they're we can test on and learn. I'm pretty happy working on boat motors and NASCAR, circle track engines or drag race. But from a horsepower guy, I would say the drag racing thing's done probably the best. We pro stock is obviously fantastic, and that's everybody's dream to do that kind of work. And that's really interesting, but it's also very frustrating because it's hard to find that next little bit. For 10 things you try, 9 of them probably aren't going to work.
Right, right.
Dave, I was curious, in talking about all the different engines that you got your hands on and all this different product development that you're doing, especially with the billet stuff. Um, what type of technology and what type of machinery are you using to help, design that and get it done? Are you using things like FEA or CFD in the design of some of this stuff? And then talk about some of the machinery that you're using.
So we do our cylinder heads on 5-axis pedals. Or I'm sorry, not pedals. I got a number of pedals, but we do our cylinder head work on 5-axis centroids. We
Okay.
have 2 of them, and then we have a new one Epoch, and then we have some pedal 3-axis and 4-axis machines, and a big Haas horizontal. Um, um,
And then are you using any type of software to help in the design of that stuff? Or are you putting that all into the CNC to kind of create out of your head and whatnot?
So we obviously use model in a CAD software, and I've owned a couple different CFD modeling softwares that I've spent a lot of time on. Um, I can't really say that it was interesting. It was interesting to look at and interesting to work with. Um, but at the end of the day, I'm not really sure it made me more horsepower. Okay. Um, whenever you get look at things that it makes you think about it, it probably did. It was probably time well spent. But when you start doing those kind of things, they're very time consuming. Um, so FEA analysis, we haven't done too much of that. We worked with some other companies that we've enlisted, and they've done some of that for us, but most of it is kind of trial and error.
Yeah. All right. And then similar to Dan's question about a favorite engine to work on, do you have a favorite component to see go from a chunk of billet aluminum into a completed, product?
Heads and manifolds for sure.
Yeah.
That's what we do the most of, and we get the best feedback on. We've done a lot of testing. you know, we can, it's relatively easy on the dyno to move cams around and change rocker ratios and swap out intake manifolds and do that kind of stuff. So those kind of things, you can learn quite a bit about what to do next and give you some direction. So definitely heads and manifolds are my favorites.
I'm sorry, real quick, going back to manifolds, when we spoke, you mentioned to me, you said the fundamentals haven't really changed much in the last several years, but we just keep refining them. I'm curious where you see development headed. Like, what's the next frontier for intake manifolds? Do you think?
Um, I guess it depends on where racing goes, right?
Yeah.
I think racing, we're going to continue racing internal combustion engines and but right now the rules have been about smaller tires and really taking away some of the it's more been about power management than it has been about making more power. These engines, they with it in a boosted form, it makes so much power nowadays. It's all about controlling the power, not necessarily making more. Um, Naturally aspirated racing, hopefully will continue, but it's so costly to test and build those engines that there's a very small group of people that do it anymore, and hopefully that continues because that's really fun to work on.
Obviously, you're known for making big power on the drag strip, and you talked about, marine. I mean, you'll pretty much tackle anything. But I don't know if a lot of people know how heavily involved in the pulling market you are. Where did that get started, and how did that come about? And what's your scoop on that?
Well, I'm a naturally aspirated guy by trade, right? I've always made my living by making more horsepower, mostly naturally aspirated, and then we started doing some billets, and we started doing billets because the Australian pro stock stuff didn't have a rule against that, and at the time, some of the castings we were working with, we just had a lot of trouble with them leaking when we were trying to move ports around and do things like that. So we thought, well, heck, we'll just make it out of a piece of billet. And so that kind of got started. And then, of course, the billet world is great for the boosted. So we started learning a lot about boosted engines, and obviously that's a really good market for a billet product. So the nice thing about the pulling world, we do mostly naturally aspirated pulling, the 650s and the like the big naturally aspirated motors, 800 type cubic inch engines, and they allow billet components. So it's a nice fit for us because I love doing the naturally aspirated components, but also they allow a billet, so it gives us best of exactly what we want.
Yeah. Do you see that world expanding for you, or how's the growth in that one?
I think so. I don't know if polling is going to get bigger. It looks like the count, the truck counts are good. At Bowling Green last year there was a lot of trucks, just like there always is. So I think polling is going to be continue going good. Um, you know, Definitely it increases for us every year. We're doing more and more polling engines and combinations. So hopefully it does. I enjoy working on those things, and hopefully we do more of it.
What are the challenges? I'm just curious if there's one or two that stick out in your mind. Are the challenges that you face in that particular market very, very different from, like you said, drag or marine or those types of applications?
Um, the drag race is pretty easy. Drag racing is pretty easy to see if you have horsepower. If your car weighs X and you run a big mile per hour, if you run more mile per hour, you probably got more horsepower, right? In polling, there's a lot of skill involved with those guys. They put a lot of effort into how they prep the trucks and how they do that. Um, so so the customers, um, getting good good engine components in the hands of the guys who pull really well, those pay huge dividends.
Yeah.
So, like I say, everybody wants to go with the people that are winning, and you can't really see horsepower on a pulling truck. You only see the result of the competitors pulling. Does that make sense?
Yeah. Yeah.
Okay. And it's that way in a lot of types of racing, like circle track racing, of course, too. If a car is coming off the corner 5 mile per hour faster, he's going to be faster at the end of the chute, right? So he does the guy pulling down the straightaway um, doesn't necessarily have the most horsepower if the car corners really well. So in the pulling world, it's really hard to see 20 or 30 horsepower. But they're definitely serious about their sport, and if you prove that you got the best product, I think they'll continue supporting you.
Excellent. Well, Dave, we covered a bunch of different things from engine platforms and combinations to components and some things in between there. But we wanted to give you a chance if there was anything that we didn't quite touch on or just anything else that you have going on currently that you want to elaborate on, please do. Let us know what kind of currently has your focus.
Um, you know, One of the things we do a lot of right now, and it just happened to work out this way, is we sell a lot of flame hoops.
Right.
That has turned into a huge market for us. When we did I never heard of this, 10 years ago, and we did some fathead Hemis. We did some pro mod style Hemi cylinder engines, and we saw that the pro mod and top fuel world has been doing this for a long time. So we started making top fuel hoops or flame hoops for all the applications, and that has really grown into a nice market for us. If you're not familiar with how that works, it's basically like O-ringing, but the hoop rather is basically an O-ring on steroids. It's got a 20-thou radius on one edge that goes into the gasket, but it's 80 thousandths tall. So it's machined in a lathe as a hoop. So you can set the protrusion depth up higher. We normally set it at 20 thousandths off the deck. That compresses into a copper head gasket, which pushes into a receiver groove, which completes the compression seal. And years ago, it used to be the head gasket was a fuse, and you missed on the tune-up and you push the head gasket out, and you fix that. Well, with the way we do the flame hoops now and get that good seal on the combustion, it finds the next weak link. But from a standpoint of holding the head gasket, it worked really well.
So at this standpoint, are you putting out engines without the flame hoops involved, or maybe some of the naturally aspirated stuff doesn't maybe require it, but I would guess that most of the builds you're doing has them.
Yeah, almost everything boosted or nitrous has it nowadays.
Yeah.
A lot of naturally aspirated stuff is MLS. That MLS gasket still works fantastic. They make what they call a mini hoop now. Yeah, some people have approached us, and other people have been doing it. Where rather than having that hoop out with a 20,000 protrusion, you just put it out with a 5,000 protrusion, and then you use it with a MLS gasket without a receiver groove. So it just puts extra pressure on that compression seal, and so a lot of guys are doing that with that what they call a mini hoop. But pretty much everything is either a copper gasket with a hoop or a MLS gasket nowadays.
Okay. And Dave, you were telling me that, again, you mentioned that the flame hoop stuff has become pretty big for you, but you also field quite a few questions regarding it. What are people asking you, or what are people still trying to figure out about the flame hoops, whether it's the component itself or just, how it gets put into the engine?
Yeah, mostly installation techniques.
Okay.
You know, a lot of guys do it like we do on a CNC machine, but also a lot of people use the BHJ tooling, which works real well too. And the first couple times you do it because it is a solid hoop, that it's got to be right on size. You can't miss on the size, and um, just um, just the technique of getting it installed, and getting that hoop in there. Once they figure out their method of doing it, and how to go about it, they go really well. But the first couple times to do it can be a little bit frustrating until you figure out your formula.
Yeah, I can imagine it definitely takes some precision to get that to mate properly and just be in the exact right spot. So
The only other thing I was going to ask, Dave, I mean, you've built such an impressive legacy in the performance industry, and you've accomplished so much. I'm just curious, what's next for David Visner? Are there any dragons left to slay in your world, or what are we looking forward to?
Yeah, so we're taking on more and more R&D projects. We we have um, a number of interesting projects that we're really excited about. So there's always an interesting project out there next. So we got a lot of nothing specific, I guess. It's more of the same, but you know, continuing the what we're still working on. When we worked on the Godzilla stuff with Ford, um, I learned a lot about how manufacturing actually gets done, and how the manufacturing world does things in comparison to the racing world. And so that was really interesting. And so we have a lot of the Godzilla stuff still in the works. We're doing a lot of stuff with Godzilla. Um, but most of it's still the billet stuff, and we definitely want to take this water jacket engine combinations to the next level. We talked about doing some V12 stuff for the marine market. Um, um, we got a super stock Hemi project in the works again, which we're real excited about. We love super stock Hemi racing. Um, so there doesn't seem to be any lack
yeah,
of projects out there.
Yeah, whenever
definitely.
you want to spill the beans, I know we're always interested to hear about it. So,
All right. Yeah. We'll, hopefully from a winner circle.
There you go. There you go.
Yeah.
Awesome. Well, Dave, uh, obviously you got a lot of irons in the fire there, and continuing to do some awesome stuff. So, we appreciate that you got a busy schedule and taking some time out of that to speak to Dan and I. So, really appreciate that. And guys, we appreciate all of you watching this episode of Intellectual Horsepower. Make sure you are checking out everything that Dave and his team do over there at Visner Engine Development. And as always, make sure you're checking out enginebuildermag.com for more awesome engine content. We appreciate you watching, and we'll see you guys next time.